Hello, statistics students, and welcome to your virtual statistics class. This is Ms. Howell, and this video will do two things. It will walk through how we will use Canvas in our class, and it will also talk a little bit about our content, which is the normal distribution. So first, I would just like to remind you that your assignments will be posted in Canvas. They'll be posted at the very top of the screen where it says Statistics Assignments, Students Read This. And if I click on Howell Statistics Weekly Plan, you will see, this loads here, you will see the plan for the week. So you can see that the course is Statistics, Period 2, with Ms. Howell. My office hours are from 9 to 10 a.m. And then I'll be posting our lesson objectives, our instruction. Most importantly, on the right-hand side of the screen here, I will post the assessments and I will post the links to the assessments. So I'll have some little assignments for you to do, and maybe I'll have some medium-sized assignments for you to do as well, and they will be posted in this weekly plan. As we go on with our closure of school, you'll see things posted in future weeks. Okay, so back to the modules. I think most of you, hopefully all of you, are familiar with how I've set up the course. We are in Unit 2, the normal distribution, and I've got day dividers in here, and I'm going to scroll down to Friday, March 20th, which is our next class, and it's a virtual one. And you can see we've got the notes, the video notes, which I'm posting, and then the two assignments under Friday, March 20th. After you watch this video, you may want to participate in a Canvas conference. And a Canvas conference is an opportunity for you to talk with me. So conferences are on the left-hand side of the screen, and when there is a conference, you will see one here, and you can hit join, and you'll be able to join me in a conference. So we will try that out on Friday. I will start a conference, and you can join me if you are able to. There's no requirement to join the conference. I will be running conferences at the same time that we have class. If you have questions outside of when we would normally have class, then just go ahead and email me and we will figure it out. Okay, so what I'm going to do next is I'm going to scroll back down to the bottom of the page and find our notes. And if you would like to download these and follow along with me, you may. These are our Chapter 2 notes. And I'm actually going to switch over to Notability. And I'm going to talk about these notes. So we were at the bottom of the page in the third section. And we had not talked about this yet. We had not yet talked about what standard deviation actually means. So we did, however, do an activity where we learned that standard deviation is similar to mean absolute deviation, which means average distance from the mean. Okay, to calculate a standard deviation, what we would need to do is use an online calculator, and I'm going to suggest that we use my very favorite online calculator, which is called Rossman Chance. So I've got my numbers here. Here's some sample data. The longevity of different domestic, oh, that's weird. I've never made a parallelogram before. The longevity of different domestic animals. What I'm going to do is go back to our Canvas course, and I have got our Rossman Chance in here. Oops. Actually, I take it back. We're not going to use that Rossman Chance. We're going to go back to Rossman Chance. You may remember this Rossman Chance. Here we go. rossmanchance.com/applets. And we're going to go to descriptive statistics here. I'm going to click it, and I'm going to clear this, and I'm going to put in our data, and I'm not even going to put in a header. I'm just going to type in the data. So we've got 12, 15, 12, 12. Let's see what we've got here. Okay, 8, 4, 20, 10, 5, 12. All right, so there's my data. I'm going to use that data, and we've used this before to make a dot plot. You can also make a histogram or a box plot. But what I want to use it for this time is to find the standard deviation. So if I click this actual box, I can find the mean, median, the interquartile range, and the standard deviation. So that's really handy. That's how we would find the standard deviation, is using rossmanchance.com. And again, when we find the standard deviation, we want to remember that it's basically an average distance from the mean. So if I go back to this screen with my statistics on it, I see that the mean is 11 and the standard deviation is about 4.6 or 4.7. So the mean is 11. That means the average longevity, or the average amount of time that these animals live, is about 11 years. And then the standard deviation is about 4.7 years. So you can see when I look at these numbers, like the middle of these numbers is about 11, but then some numbers are bigger and some numbers are smaller. And standard deviation is a measure of that spread. And coming up, we're going to see even a little bit more, in a little bit more detail, what standard deviation means. Okay, so standard deviation, it turns out, is really, really useful in something called the normal distribution. And the normal distribution, you may recall from our work in the popcorn lab, is this mound-shaped, or sometimes people call it a bell-shaped curve. So mound-shaped or bell-shaped. And we've seen a couple of reasons for this curve. We saw it when we measured something. We saw it in the marble lab. We used calipers to measure marbles, and we got this shape of distribution. We see it in population, so we saw it in the popcorn. And we also see it in random processes that are repeated numerous times. That's a little bit beyond where we're going to go today, but those are called sampling distributions, and they're really fundamental. So we see these mound or bell-shaped curves. They come up all the time, and they have certain properties. And the first property is that the center of the standard normal distribution is the mean. So when I sketch the standard normal distribution, the center of it is our mean, or average. The standard deviation is the measure of spread. Now, we've been practicing a lot in this class how to find the standard deviation. First, we locate the inflection point, which is about halfway over and halfway down. So if I look at this whole thing, if I think about halfway down is about there. And then this distance between the mean and this green line is the standard deviation. And remember that when we graph things in math, we've got a number line here. So we would be able to actually measure that standard deviation. Since all normal distributions have the same shape, you can shift and stretch them to match the standard normal distribution, and that's what we're going to practice doing today. And then the other thing we need to recognize is that the total area under this distribution is 1. What that stands for, 100%, or all the possibilities. This represents all the possibilities, and there's a 100% chance that we've captured all of the possibilities. Okay, next, another term is the Z-score. The Z-score is defined as the number of standard deviations from the mean. So, going back to, let's use this data that we calculated up here. We had a mean of 11 and a standard deviation of 4.7. And I bet you won't be too mad at me if I just get kind of lazy / efficient. We're just going to say, let's round it to 5 years. So if I go back to this graph, if the mean is 11, then one standard deviation above the mean would be 11 plus 5, or 16. And one standard deviation below the mean would be 11 minus 5, which would be 6. And I can keep going like that. Now I can measure out 2 standard deviations. I would add 5 again to get 21. And 3 standard deviations, I would add 5 again to get 26. Now what happens on the left side is when I subtract 5 again, I get 1. And I can't really subtract 5 again because I can't have a cat that lives -4 years. It doesn't really make any sense. And that's okay. This is an approximation. So it doesn't always work out perfectly. So what we're going to be able to do is we're going to be able to use this to solve some problems. What this graph tells us, this graph right here, is it gives us an estimate of how long these animals, this was longevity or lifespan of domestic animals. So now I have a way to compare animals to each other. I can say, wow, if there's an animal that lives to be 21 years old, there's not very many animals that live to be older than that. If I have a domestic animal, like, I don't know what, like maybe a gerbil that only lives to be 1 year old, that's also kind of an unusual case. You will also see this applied to standardized testing. Here's an example where it says, in a recent year, the distribution of SAT scores for the incoming class at the University of Washington was normal in shape with a mean of 1,055. So I can sketch this, right? It's normal in shape. I sketched the shape. Mean 1,055. So the center is the mean. And a standard deviation of 200. So we'll just do this kind of quickly here. So that would be 1,255 and 855. So I have a sense now that most of the students at that school have test scores between these two numbers. And a student that scores above that is doing pretty well, and a student that scores below that is not scoring as highly as most of the students at that school. Okay, we'll come back to how to solve these in a little bit. I want to move on to more examples. So let's use an example to visualize this. It says the heights of males 18 to 24 in the United States are approximately normal with a mean of 70.1 inches and standard deviation of 2.1 inches. What percentage of these males are more than 74 inches? Okay, so first, any standard normal curve has this shape, and we did this in the popcorn lab. These are called the Z-scores. So the center here, 0, that's my mean. And then when I say plus 1, what I mean is plus 1 standard deviation. And when I say plus 2, I mean plus 2 standard deviations, and so on. And that is going to look the same for every single problem. What changes is the scale. So when we say that the mean is 70.1, that goes in the middle. And this variable that I'm working on here is heights. And a standard deviation of 2.7 inches. So if I add 2.7, I get 72.8. And if I subtract 2.7, I'm going to get something. Let's see, 0.4, 67.4. So the question is, what percentage of these males are more than 74 inches? If I were to sketch this, 74 inches, I don't know exactly where it is, but let's say it's right here. The idea here is that this area, this purple shaded area, represents people who are taller than 74 inches high. And guess what? There's an app for that, and the app for that is called Rossman Chance. So right now what I need to remember is 3 numbers. Let's see how good our memory is. I need to remember 70.1 is the mean. I need to remember 2.7 is the standard deviation, and I need to remember I want greater than 74 inches. So I'm going to shift back to here, and I'm going to go to the normal probability calculator. And I'll open it in a new window. And my variable is height. And my mean was 70.1. Oops. My standard deviation was 2.7. So I'm going to start with that. Scale to fit. Okay, so there's the graph. It did it for me, and look what it did. It shows me where the center is, and it shows me the z-scores. And now what it's asking for is the probability, and I just turned this around because I want the probability of having a height greater than 74 inches. Just hit return. So this probability calculator is really, really snazzy. Okay, I'm going to screenshot this so I can draw on it. So again, it's giving me the z-scores. You can see the z-scores down here at the bottom. The z-scores again are how many standard deviations from the mean. The mean is the center, and the mean height of men was 70.1 inches. Let's think about that for a minute. 70.1 inches. So there's 12 inches in a foot. So let's see. So 5 feet is 60 inches. So this would be 5 foot 10 inches. So we're saying that the average height of a man, according to this problem, is 5 foot 10 inches. And 74 inches, which we put, which the question asked us about, 74 inches is about 6 foot 2, I think. Is that right? Because 5 feet is 60 inches, 6 feet is 72 inches, so 74 inches is 6 foot 2 inches. Okay, so what did we figure out here? We figured out, over on the left, that the probability of being taller than 74 inches, or 6 foot 2 inches, is 0.07. or 7% of the population. That's what this probability calculator does for us. So back to our notes. So we figured out that this probability, or this area here, is 0.074, which is about 7.4%. Remember, divide by 100 to convert to percents. Woo! Okay, so that was this one. Let's try another one. This one says the heights of females 18 to 24 in the United States are approximately normal, with a mean of 64.8 inches and a standard deviation of 2.5 inches. What height separates the shortest 75% from the tallest 25%? I'm going to use the normal probability calculator again, and I'm going to have to remember the mean, 64.8. The standard deviation is 2.5. And the shortest 75%, it's going to be something like this. So more than half. We're looking for this line that divides the shortest 75% from the tallest 25%. So I'm going to shift back to my probability calculator. And, oh no, I already forgot my number. 64.8 and 2.5. 64.8 and 2.5. Not 2.t, 2.5. Okay. Scale to fit. There we have it. So it made the graph for me. Now, we want to know the 75th percentile, which is a probability is 0.75. Oops. Nope. I'm going to switch this around. All right, there we go. That's looking right. So here we've got the shortest 75%, and it tells me right here, it's a little bit hard to see, but it tells me that that height is 66.4 inches. So that is the line. Let's see, I'll screenshot this one too. This line right here is at 66.4 inches. So a woman who's shorter than 66.4 inches is in this bottom 75%, and a woman that's taller than 66.4 inches is in this top 25%. Switching back to my notes. Oh, it doesn't want to go. Done. Okay. Okay. We are going to skip this last part here. I may do these examples at the end on another day, but for right now, we've done a few examples using the normal probability calculator. And what I'd like to talk about next is what your next steps are. So if we go back to Canvas, I would like you to do two things. One, I'd like you to do this digital learning quiz. And I'll just give you some hints on this quiz, and then you can go do it, okay? In Canvas, there's a way for Ms. Howell to give notes and for students to ask questions in real time. The name of this feature is Conferences, and you can access the conferences on the left side. I will open up conferences after 8:30 on Friday. The document that tells students where the learning objectives is stored is called the weekly plan, and I'll store it at the top of the Canvas homepage. If I have a question about stats, how can I contact Ms. Howell? I would like you to contact me through Canvas, Google Voice, or email. Although, well, no, I don't want to see your TikToks yet. We'll see how this thing all plays out. The online statistics calculator, we know the name of that is Rossman Chance/applets. And the content in Canvas is organized by modules, then dates. Okay, so I'd like you to go take that quiz just to show me that you understand what's going on in here. And then I'm going to ask you to do an assignment related to this, related to the normal distribution. So that is assignment 2. And it's on ClassKick. And it should put in the, make sure you log in with Google. Oh, will it do it? This is always good to check. You can do it, little iPad. There we go. So you might have to give it a try or two. So then in class kick, you'll see your assignment. So the normal distribution is shaped like what? So you'll be able to type in, when you're taking this as a student, you'll be able to type in your answer. We just saw that the normal distribution is shaped like a bell or a mound. Okay? As you're working on this, I'll be able to see your writing and I can give you assistance. I will also set this so that you can see if you're getting the answers right, so that you'll get some feedback in that way as well. If you have questions, please contact me. I'm looking forward to this new experience together. And yep, I'm here for you virtually. I'm not here for you face-to-face, but I'm here for you virtually. And best of luck.